Hello Spark fans and welcome back to Advancing Spark, where today we're going in a different direction to normal because we're going to be looking at a thing called Terraform. So we had a big announcement recently coming from Databricks saying that Terraform Provider is now GA. And for people who aren't using Terraform, that doesn't really mean anything. So similar to how we did with data science, we're going to give you a bit of an intro to DevOps, infrastructure as code, Terraform, set the scene about what all that stuff is, and then we'll start looking at how to actually use the Terraform provider in future videos. We'll build on it and we'll go and have a look at that stuff. If it is your first time here, as always, don't forget to like and subscribe. Let us know down in the comments if you're currently using the Terraform provider, or if you're a fan of other things. Are you using Bicep, Pulumi, any of those other ones that are out in the wild? As we mainly see Terraform, given there is now a GA Databricks provider, but it'd be good to hear what you guys are using. So before we get into the detail of things, I'll get up the blog post. So we had this thing out there. You might have seen it going out from the Databricks official blog. The Databricks Terraform provider is now generally available. And I will admit this kind of caught us a bit by surprise because I thought it was already GA and we're using it going, yeah, okay. It's now actually GA. Now, there's two big things for this. Firstly, this is one of the main releases from the Databricks Labs that's actually made it to GA. So Databricks Labs is this whole thing that Databricks run internally, where they build lots of internal programs and solutions and things, and then they like publish it out. It's essentially their little scratch pad of interesting community projects that their various different solution architects are working on that we can then pick up and use. It's great to see the Databricks Terraform provider actually reach a production state, and it's been published, formally hosted, part of the Terraform registry, all of that good stuff. So there's a load of information in there. I'll share the link with that so you can go and have a look at all the different things they're talking about in there. But as I said, we'll give you a bit of an intro. Today is a bit of a grounding session. What is Terraform? How does it work? How does it fit in? Why are we using it? And then we can go through how to actually use the Databricks registry in a later video. Hopefully all of that makes sense. Now, I'm not a DevOps expert. I've written a fair few DevOps pipelines in my time, but I haven't actually got my hands dirty at all going through this stuff. I thought we would bring in our resident DevOps expert inside of Advancing Analytics. So we're going to switch over and have a guest. So welcome to the show, Anna.
Thank you. Hello.
So you're going to teach us all about a little bit of a background about where we're coming from, why DevOps, why infrastructure as code, and then a bit about what Terraform is. Sound good?
Yes, perfect. So DevOps, what exactly is DevOps and why is it important? So what we've got here is the magical figure of 8 that anyone who's worked in DevOps before will have seen. And this figure of 8 is the dream. This is the DevOps dream, and this is what we want to accomplish, not just in software engineering projects, but when we're also working in our data projects as well. And it includes everybody in the team. So not just that one person who's really good at their stuff. This is something that everybody should be involved in. And what we're looking at here is essentially we code, we build, we test, we release, we deploy, we operate, we monitor, we plan, and we keep going around in that figure of 8, and we all work together to achieve this dream. So the solutions that we're working on are in that constant flow, and they're constantly improving and they're constantly being tested.
Yeah, no, I mean, I do entirely agree in that whole process of DevOps isn't a role. There isn't a DevOps person.
No.
It's if DevOps is working, everyone takes care of it because it's bringing the two together into a seamless thing, right?
Exactly. Yeah, everybody owns it.
Sense. All right, so in that case, so that's DevOps. What's this next thing? What's infrastructure?
Yeah, so there's different parts of DevOps. There's the what you would automatically think of is actually getting your solutions out there. So say if you're writing some Python code, getting it out there into the wild, into production. And that's one element of it. But we need to think about the infrastructure, where exactly that's going to live, what platform that's living in. And that is essentially where we have infrastructure as code. So essentially with infrastructure as code, you're not going into, say, your cloud provider, say Azure, and creating infrastructure there. So we're not creating databases there. We're not creating instances of Databricks there, for example. We're actually doing this as code. So by using code, we can essentially automate the creation, update, destroy, and cloud and basically delete your cloud infrastructure, all essentially using the code. So it's something that is reusable, you can share it, you can version it, and it is essentially owned again by everybody. And what you get out of that is you essentially have a blueprint. So that blueprint is the same as if you were building a house. That blueprint is telling you what you're going to be creating, what you're going to be deploying, what you're going to be updating. And you can look at that, and anyone should be able to look at that and understand how your infrastructure essentially hangs together.
And so I'm not allowed to go in the Azure portal and just like click create and just like build the things as I want.
It's a bit of a Wild West if everybody goes in there and does that and starts tweaking things. It becomes a Wild West, it's a black box, and then things start going wrong. You don't know who's configured what, why it's doing what it's doing. And by having the infrastructure as code, which is your blueprint, you've got one source of truth in one place where you know this is how the infrastructure should look. And if we want any infrastructure to change, we can then essentially have things like gating on that, on pipelines and DevOps pipelines, essentially, where we would make sure that things are checked before they're changed. And that's super key when working, obviously, in like test environments and production environments. We want to make sure that we're validating any of those changes, and we haven't just got somebody going into the Azure portal who's got the right privileges and starting to tweak the infrastructure.
And I guess anyone at home who's ever developed anything and found that their production environments deployed slightly differently to their test and dev environments.
Yeah, exactly.
This is why you need this stuff.
Exactly. Yeah, you're getting an absolute mirror image in each environment of the infrastructure, so you know it's going to be working in exactly the same way.
Right. So in that case, if they're the good things, we're aiming to have a good DevOps lifecycle. Part of that, we want to have infrastructure code working.
Yep.
Next question: what's Terraform? How does that fit in?
Yeah, so there's been quite a few tools that have come onto the market essentially to tackle this problem. So infrastructure as code tooling, all with different strengths and weaknesses. And kind of off the back of that, we've got Terraform. And essentially what Terraform is infrastructure as code, but it's taken some of the good bits from the other infrastructure as code tools and compiled it all together and created this solution, which is essentially it's cloud agnostic, so you can use it across Azure, AWS, GCP. You can basically, it's got provisions, managers and versions, it's consistent, it's reusable. So essentially it's giving you a perfect out of the box infrastructure as code tool, which is easy to use and easy to pick up.
Yeah, so each of the cloud platforms has kind of their own way of doing it. So
yeah.
I guess in Azure, we're used to using ARM templates, the Azure Resource Management templates, and kind of more big gnarly bits of JSON, and we deploy those specifically. So this is like an abstraction layer that sits above that kind of manages for us in a simpler way.
Yeah, so Terraform is written in basically it's a human readable way. So when you're looking at your Terraform files, they're a lot more simplistic than, say, if you were looking at ARM. When ARM becomes complex, it becomes more difficult for others to understand, especially when you're trying to deal with things like dependencies between different pieces of infrastructure. The actual execution process as well is a lot more complex than Terraform. Terraform does everything essentially. Either you're writing the Terraform in your Terraform files, which is like your blueprint, or you're using the Terraform CLI with the Terraform commands essentially to enable you to actually check what you've been writing, validate it, do a plan which will essentially allow you to see what's actually going to happen when you actually deploy this, and then you can do the apply, which is the deployment process. And the whole time Terraform holds your hand a lot more through the process and gives you a lot more feedback every step of the way, so you feel more comfortable that what you are doing isn't going to blow up say your production environment. And then essentially, once you've got that, you can even hand this to other people in your team and say, right, this is my Terraform plan. What do you think? Is this okay? Is this it's saying it's gonna tweak this resource here. Is that all right? Or is that gonna break something? And you've got that clear picture then of exactly what's gonna happen. And essentially Terraform is doing that with a few simple tools. So again, it's for anyone to pick up. It's human readable, and so it's a great tool when you've got people in your team that essentially have different skill sets. So we're not all developers, we're not all database experts. We've got different strengths and weaknesses, and Terraform is a great tool for those sorts of teams where you've got a variety of skill bases, which is really important in data teams. A variety of skill bases and you can say, right, we can use Terraform and everyone can look at it and understand it.
A lot of sense. Alrighty, so you're going to teach us a little bit of the terminology from Terraform.
Yes.
Okay, so I've got a slide duty. So next slide.
Right. So, we were talking about this kind of easy visualization. So we're talking about doing plans before. Essentially, when you're doing a Terraform plan, it will give you an output in the CLI of what exactly is going to happen, and you can use that again, say, pass that to another person in the team. But what you can also do is visualize those sorts of things. So you could visualize the plan. And what we're seeing here is where we've been able to visualize all of the resources. So this is basically a resource graph, and we can have this nice pretty visualization that says this is how it's all essentially hanging together. So we're creating there like a storage account and a data lake, and it's telling you essentially how does that all hang together, what are the relationships. And so this is really, really useful and really powerful, because this is something we can pass to anyone in the team, or even kind of management people higher up in the business who aren't as technical as yourselves, and say, right, this is how it's all hanging together. This is what we're going to be doing in our next deploy. If you had a visualization of your plan for your next deploy, and it's not showing them a load of code or the output of the CLI in a terminal, you're actually giving them a visual tool. And that's, again, it's really powerful, and it really gets everybody involved, and it gives you that sense of security and understanding essentially over your infrastructure as code.
That's good. Okay, so that's resource graphs.
Yeah.
Next, the execution plan itself.
Yeah, so as mentioned, we have the Terraform CLI. So we create our Terraform files, and that's our blueprint. But then we work with the CLI to essentially actually do the compute, so the actual validation and getting the resources into production, into our cloud environments. And what we're looking at here is just where essentially we've run a Terraform plan command. It's looked at our Terraform, and essentially what it's done is it's figured out what exactly is going to happen. And what it's showing us here, and we're seeing those green X's, and that means it's going to add something. It's telling us I'm going to create a key vault, and I'm going to create a resource group. And essentially it gives us the name, it gives us other useful information, and we can review this plan and say, right, yes, this is exactly what I want to happen. But if you see there on the bottom line, it's saying 3 to add, 0 to change, 0 to destroy. You may for example, have a gotcha where it's saying, actually, I'm going to destroy something. It may want to destroy something to then recreate it, but that essentially could be catastrophic in your environment. And this plan is like the safety net. This output is telling you what's going to happen, and you can say, actually, no, don't do that, and actually backtrack and figure out why it wants to do that, and put the right processes in place to make sure that if it does need to be destroyed, it's not going to cause a massive problem. So, for example, you might want to say, actually, I'm going to need to do this in the middle of the night. So we can actually tear it down and then apply those new changes. Or it might be attempting to do a destroy essentially in error because something's been renamed, and then you can tackle that. There are ways in Terraform to actually tackle that, to work with the naming and things in what we call the state file, and make sure that everything is synced up accordingly.
Pretty cool. I mean, just any kind of safety net in a DevOps process is great, right? Because that's the whole point of DevOps, is to reduce the risk of doing a deployment. And if you can reduce risk by checking it's not going to break before you do it, fantastic.
Yes, and we can get anyone writing this and creating plans. They don't have to have the full access in the cloud environment. They could be creating their plans and just getting that feedback as to what exactly is going to happen. And so they can feel comfortable creating the infrastructure as code, even if they're not the ones to hit that final button and actually execute it.
Right, and then the final piece, declarative.
Yeah, so Terraform is what we call a declarative language, and essentially what we mean by that is it only does what it says on the tin. It doesn't have any crazy bits of functionality that you can add. So it's not like if you're writing in a programming language where you can start typing away and doing whatever you want to do. Terraform is, you have this structure, you have these certain components that you need to use to essentially create your infrastructure as code. So whatever resource you want to add, you will have essentially resource tags, pieces of Terraform that essentially, as we can see there in the bottom of that example code, we've got a resource there. We're going to create a resource group. So every piece of resource will be literally very, very similar, but obviously the type will change and the amount of properties that you're adding in will change. But it's declarative. You can't add any new bits in or any bits of functionality unless it's actually built into Terraform, and that's what we mean essentially by it's declarative.
So when we're talking about the fact there's now a Databricks package, that's adding in various tags that you can now call part of those declarations.
Yes. So what Terraform essentially does is it will sit on top of, say, the REST APIs for the certain cloud providers for the certain types of resources, and it will utilize all of that, interpret it into Terraform, and then it'll expose it in the way we're seeing here, in where we can create those resource tags. So essentially, if you start working with the Databricks provider, essentially, if you go into the documentation, you can say, right, I need to create myself, say, a cluster. You can go in to the documentation, look up the cluster bit of code. It will give you literally a copy and paste bit of code that you can throw into your Terraform file. It will tell you this particular property is mandatory, these ones are optional. So very, very quickly, you can actually start building that up and actually start executing that and seeing that, essentially testing it and seeing that that is doing what you're expecting it to do. And you can do that against your development environments and just make sure that your Terraform essentially is working as you expect. And then once you're happy, you can then start pushing that into production. And again, it's the language, the Terraform language is HCL. It is essentially human readable by design, so anyone can pick it up. It does support loops, dynamic blocks, and local variables, and it will support complex data structures. So it's a little bit more advanced than some of the declarative tooling. Essentially, it's adding a little bit more in there. It's still structured, so you can't just write whatever you want, but there is some more going on. So it's not all just kind of static. There is some more stuff that you can throw in and get it doing what you want it to do.
Again, sounds mega useful. Okay, I think the final piece we had, talk a little bit about how it hangs together. So what does Terraform actually like from an architectural point?
Yeah, so Terraform, essentially, we have a configuration file. Essentially, we're talking about the Terraform files themselves. So any files that have got the Terraform extension, where you're throwing all that infrastructure in that we were talking about, that you can just grab from the documentation, essentially, for the Databricks provider, and you can start building it up really quickly. And once you've essentially got your Terraform file or files, you can then essentially define your state file. And what your state file is, it's essentially literally a snapshot of the state of your cloud deployment. So what you've already deployed, and then also it will also look at what is in your cloud environment as well. So if somebody has gone into your cloud environment and started tweaking something that you deployed with Terraform, the next time you run Terraform, it will flag that with you. It will literally say it's going to delete whatever they've done. For example, if they've added something to a certain resource, it will say, well, this isn't part of what I've got in my blueprint, so I'm just going to burn it. And so there are ways around that, but that's really, really cool that you've got that in there, so people can't just go in and start messing with your infrastructure, and you end up in that limbo state again, where nobody knows who did what and why certain bits of infrastructure have kind of diverged so much from, say, for example, like you said, the difference between like your test and production environments and things like that. We should always have that in infrastructure as code. We should always have it source controlled. And then moving from, any questions?
No, makes a ton of sense to me.
And then moving from the state file, so we've got our Terraform files, we've got our state files, we can then start running our Terraform commands. From there, we essentially have providers. So we need to tell our Terraform what provider we're working with. And providers essentially are going to be those three core cloud providers. So it will be Azure, AWS, GCP, Databricks. Obviously, with them, it now being generally available. I've been using it for 18 months. It is a really awesome provider, and it's made our lives a million times easier. Essentially, that's in there as well. So the list goes on and on for providers. There's loads and loads of things that you can work with out there that essentially are already providers that you can just hook into really easily, and then you're able to, from there, make the leap to actually deploying your infrastructure.
So in my head, I think of that a little bit like a PyPy, a little bit like a Python registry of libraries, except it's providers of things that Terraform can do. I want to get one of these published packages and pull that down. Am I right?
So they do have their approved essentially providers and modules that you can go and search in their documentation. Their documentation is awesome. I highly recommend anyone interested in picking up Terraform. There's loads out there, especially if you go directly onto their specific documentation for all of their providers and everything they've got on offer. And it's all there, all the snippets of code, it's all there for you to be able to grab and start working with. You don't have to worry about making it overly complex at first. Just literally throw some Terraform in a file, start running the CLI, and start essentially seeing what happens and getting familiar with it. And then you could start looking at, say, putting your state file somewhere remotely, because at first you can have it locally and just fiddle with it. And then start kind of building on it and working with different modules, different environments, and slowly but surely you'll become as much an expert as some of us at Advancing Analytics. So it's pretty easy to pick up.
All right, so on that note, so thanks for taking us through and giving us that general primer, the general overview of kind of Terraform and where it fits in. Are you happy to come back and do another video actually showing us how to get started with the Databricks registry and registry package provider thing? Yeah, sound good? Yeah,
that would be awesome. Yeah, more than happy to.
Well, I'll do a quick wrap up, but thanks for joining, and thanks for the overview.
Thank you.
Alrighty, so, oops, wrong page. There we go. So what we've actually seen, I guess, kind of putting it in context as to how big a change that is for us. So previously, when we were doing things with ARM templates, essentially we use an ARM template and we deploy a Databricks workspace and all the other bits and pieces, and we could do that. That's fine. You can parameterize ARM and get it out. One of the things the Databricks Terraform package actually gives you the ability to do is all the stuff inside the workspace. As Anna said, provisioning clusters. We used to have as an extra tack-on bit of CLI Python script getting a bit of JSON. Deploying libraries. All the actual workspace config and stuff that you can do via the API. We used to have as separate tasks in a big old DevOps pipeline that we had to manually configure. So actually being able to wrap that in the same method that you're doing your infrastructure as code, baking all that into one actual sort of related package that's managed and tested in the same way is a big improvement. So there's stuff to learn, there's stuff to get to grips with. There's the new terminology that you need to kind of start to learn, as Anna was saying, in terms of state files and the configurations and how that fits together. But there's massive benefits in terms of how you then manage your Databricks workspaces if you've got that baked into your entire DevOps process. So yeah, we'll get into it. We'll do another video. We'll show you how that works, and we'll talk about the things that we can do via the actual kind of, especially when we're doing it properly. Probably is 2 separate steps if we're doing deploy it and then configure it, but we'll see. We'll have a look at how that works. As always, thanks for watching. Don't forget to like and subscribe, and let us know down in the comments if you've started using Terraform, if you've started having a play and what you've actually managed to achieve with it. If you're using other approaches to do the same thing, let us know. We're always interested. Catch you next time. Cheers.